Welcome, my good learner, to section 2 of our session on vectors. And in this lesson, we want to look at position vectors and collinearity. Position vectors and collinearity. Collinearity. Let us start with position vector. Position vector. So what do you mean by position vector? We already understand what vectors are. So we want to know what a position vector is. So in position vector, we want to understand what a position vector is. And a position vector is a vector that originates from origin. This is a vector that originates from origin. Let us say, for example, I can sketch a Cartesian plane like that. So this is my Cartesian plane. That's my Cartesian plane. It is just a sketch. So this is x-axis and this is y-axis, and you can take this to be, this is our origin, 1 2 3, and then this is 1 2 3 4, like that. So let us take 2 points. You can take 2 points, for example, one point here whose coordinates are 1 2. We can take it to be P. So that is our point. And then there is another point whose coordinates are 2 3. And we can say this is point R. So if you look at these points, we can form a vector that is we can form vector OP. Vector OP. You can see that the tail is at origin and the head is at that point P. So this is a position vector of point P, and it is written as vector OP. So vector OP is the position vector of point P. So basically what we mean by position vector is a vector that originates from origin. And if you were to calculate this vector, then we know that if, for example, you are given OP, vector OP, then to get that vector, we'll be saying it will be the same as subtracting the coordinates of O from P. That is P minus O. That is the short way of getting the vector OP. For example, vector OP will be, you write the coordinates of P in column form. That is 1 1 2 minus the coordinates of origin. We know that is 0 0 0 0. So I believe you know how to write the coordinates in column form. We normally start with XY, like that. The horizontal displacement and then the vertical displacement. So if you want to look to write to look for the position vector of P, we will say the coordinates of P minus the coordinate of O are written in column form, because we know that we give vector in column form. So this 1 minus 0 you get 1, 2 minus 0 you get 2. So if you examine this, you will find that you can see that vector is just the same as the coordinate of P written in column form. So there is nothing that will change. What will change is the form that it is written. Again, we can find position vector of R, which is OR. The position vector of R is OR, meaning that you are starting from O to R. So how do we do that? So I can show this in the diagram. we say that we represent vectors in using straight line with an arrow. So that is it. So this is the position vector of R grammatically. Okay, now to get this, we know that we said that to get the vector, you will say the coordinate of the second point here minus the coordinate of the first point. What are the coordinates of the second point? R, it is 2, 3. 2, 2, 3. So this is just a sketch. This is it's not accurate. So you have to understand that this is a sketch, so that it will just help us to demonstrate or to illustrate the concepts about position vectors. So the coordinates of R are 2, 3 written in column form minus the coordinate of O is what? R 0, 0. So if you subtract, you get 2, 2, 3. So that is our position vector R, or the position vector of point R. So there are two things that I want you to know here. Number one, if you are told or you hear about position vector of any point, then you should know that it is starting from the origin. Say that if, for example, you are told the position vector of t, you should know that it is OT. That vector is OT. Second point that I want you to understand is how to get the vector. We are saying that to get the vector, you will say the coordinates of the second. If this is your second, for example, this is your second point and this is the first point, so you will say the coordinate of the second point minus the coordinate of the first point. That is how we can get the vector. So that is all about the position vector. And another thing that I want us to understand is that the position vector of a point is the same as the coordinates of the point written in a column form. For example, you can be given the coordinates of point P of point T as 3, 4. You need to know that the position vector of T, which is now OT, that vector will be 3, 3, 4, meaning that the horizontal displacement is 3 units and the vertical displacement is 4 units, where this is X, Y. We normally start with the horizontal displacement like that. So you need to understand that the coordinates, that position vector will just be the coordinate of the point written in column form. So another thing that coming to collinearity, what do you mean by collinear points? Collinear points are points which are in a straight line. Collinear, they share one line. These are points which are in a straight line. Collinear points. So we can write collinear points. Collinear points are points in a straight line. Are points in a straight line. So collinear points are points which are in a straight line. For example, I may have this point here, point A, B, and C. So these points are collinear. They are collinear because they form a straight line. So these points are said to be collinear. To find the collinearity or to justify the collinearity of points in vectors, there are two conditions that we have to meet. Two conditions to consider to determine the collinearity in points, the collinearity of points. Two conditions to consider to determine the collinearity of points. Number one, the vectors must be parallel. The vectors must be parallel. We shall talk about the parallel vectors. The vectors must be parallel. Number two, there must be there must be a common point. A common point. So these are the conditions that you need to consider for you to know whether the vectors are the points are collinear or they are not. If the points can form a straight line or they don't form a straight line. So we can first of all discuss what we mean by parallel vectors. Parallel vectors. So two vectors are said to be parallel. Two or more vectors are said to be parallel if you can write in terms of another one, if they are multiples of another one. For example, if you're told vector A is equal to 2, 3, and vector B is 4, 6, we are considering these two vectors, A which is 2, 3, B which is 4, 6. So we want to see whether these vectors are, you can write one vector in terms of another one. Like for example, we may multiply A with a scalar, let us say x, so that we get vector B. Okay, so we can say x multiplied by A is 2, 3, is equal to B which is 4, 6. So that means 2x will be equal to 2x, 3x is equal to 4, 6. So 2x is equal to 4. You divide by 2, you get x is equal to 2. In this case also, you can see that 3x is equal to 6. You divide by 3, you get x is still 2. So you can see that in order to get vector B, you can get vector B by multiplying vector A by 2. So we will say that B, we can say that 2A is equal to, so we can see that if you want to get vector B, you multiply vector A by 2, or you can say vector A is equal to a half of vector B. So if you can write one vector in terms of another one, then you can say those vectors are parallel. The vectors are parallel. They are multiple of another one. So that is how we identify the parallel vectors. You see whether you can write one in terms of another one. Another example may be, for example, you have vector P which can be 8, 4, and vector R which may be 2, 1. So if you want to see whether these vectors are parallel or they are not parallel, you check whether you can write one in terms of another one. And for you to test that, or the easiest way that you can see that, because sometimes it may not be easy for you to realize whether to find the multiplier. So what we do, you can introduce a scalar. For example, you can say you multiply P by anything, by alpha times vector B is equal to R. So that means alpha multiplied by P, which is 8, 4, should give you vector R, which is 2, 1, like that. So if you open the bracket, it will be 8 alpha, which is equal to 2, and 4 alpha, which is equal to 1, like that. So you make alpha the subject, you divide by 8, 1, the first equation can give you the answer, but it is good that you compare the two. You use the second one so that to see whether it is correct or not. So if you divide by 8, so you get alpha in this case will be 1/4. What about in this one? Let us prove our answer whether alpha will still be a quarter. So you divide by 4, still you get alpha to be 1/4. So one equation is enough to give you the answer or the value of the scalar, but it is good that you can use the 2 just to check your answer whether it is correct or maybe not correct. So you can see that therefore a quarter p is equal to, you substitute in our first equation, a quarter p will be equal to r. That means you multiply p by a quarter to get r, and if you want to make p the subject, then you can also say that vector p is equal to 4 times vector r. So you can see that you can write one vector in terms of another one, and if you are able to write, if you can write one vector in terms of another one, or a vector is a multiple of another one, then you can say that those two vectors are parallel. Then, so that is the first condition for collinearity. The vectors must be parallel. Another condition is if there is a point that is common, one point that is common. For example, we were considering our point A, B, C. We are considering points A, B, and C. So we know that a point is not a vector. A vector is aligned with what? A direction. So you can use these points to get vectors. For example, you can get vector AB and vector BC. Vector AB and vector BC. So you see, you check whether these vectors are parallel, which I know and I believe you have understood how to test that. Then also you see whether there is a common point. Like now here we have AB, and in this case, in this side we have what? BC. So you can see B is common. In this case, point B is common. Point B is common. Point B is common. So you can see there is a common point here. Also, you can consider AC. You can consider vector AB and vector AC. Vector AB and vector AC. You can form that vector. We also see that we have a common point. A is common in this case. A is common. So if you tested your vectors and found that they are parallel, and again you can see that we have a common point, then you can conclude that those points are collinear. They can form out a straight line. And if you do that, you test that using experiment, you will identify that they indeed form out a straight line. So having known that, I think now we are able to do questions. To do a question. So number one, you're told the position vectors of points A, B, and C are OA. So you're given OA is -3, 4, and OB is 1, 2, and OC is OA is -3, 4, OB is 1, 2, and OC is 7, -1. Then you're told show that A, B, and C are collinear. So we say that to test for collinearity, there are two conditions that you have to consider. Consider two conditions. Number one, whether vectors are parallel. Number two, check whether there is a common point. A common point. Whether there is a common point. So what we need to do is that we can draw something like a triangle, because we're talking about the position vector, and we say that in a position vector, it means that a vector that originates from origin. And so because we don't want to use Cartesian plane, we can illustrate this in a diagram like that. And you can say, for example, can represent this where this can be A, B, and C, like that. So whenever you are given position vector, it is good that you can draw a triangle like that where this is origin. It is not drawn to scale, this is just what a sketch. So OA, we are told vector OA is -3, 4. And vector OB is 1, 2. And vector OC is 7, -1. Like that. So you are told to prove whether they are collinear, whether these points are collinear, whether they form a straight line. So what we need to do, we need to introduce vector. You are given points, but you can introduce what? Vector. So we want to introduce vector AB and vector BC. Vector AB and BC, so that we have a common point. You can see that there's a common point, which is B. Vector AB and vector BC. So let us find vector AB. So how can we get vector AB? So we know that AB is equal to AO plus OB plus OB. Vector AB, this vector here, vector AB is equal to vector AO plus OB. So vector AO will be equal to negative of vector OA. So it will be negative of -3, 4, because the direction is against the arrow. We know that OA is -3, 4. So AO will be negative of this plus OB. OB is just in line with the arrow. OB is in line with the arrow. So it will be 1, 2. So that will give us negative times negative is positive. Negative times positive is negative plus 1, 2. So if you simplify this, you will get 4, -2. You get 4, -2. So that is our vector AB. So our vector AB is 4, -2. Then now we need to consider vector BC. Vector BC, this one here, vector BC. So to move from B to C is the same as moving from B, O, then O, C. So this is the same as BO plus OC. So BO is against OB. So it should be negative of OB. So which is negative of 1, 2 plus OC is in line with that. So it is -3, -7, 1. So if you simplify this will be -1, -2 plus 7, -1. And if you do that, you will get 6. You'll get 6, -3. 6, -3. You get 6, you get 6, -3. So that is our vector BC. So our vector BC is 6, -3, and our vector AB is 4, -2. So now we need to see whether these vectors are. We want to see whether these vectors are collinear. So we know that vector AB is 4, -2, and vector BC is 6, -3. So I said before that for you to test whether they are collinear, you just multiply a scalar by one vector and you see whether you equate with the second vector. Like for example, we can say XAB is equal to BC to see whether they are multiple of another one. So you can say XAB is 4, -2 is equal to 6, -3. So I mean 4x -2x is equal to 6, -3. So we can form equation that is 4x is equal to 6, whereby if you divide by 4, you divide by 4. Divide by 4, what do you get? by this you get x is equal to by 2 by 2 2 by 2 3, which will be 3 all over 2, 3 all over 2. So in this case we are getting x to be 3 all over 2. So we want to prove our answer whether it is correct by considering the second equation. So we will say negative 2x will be equal to negative 3. You divide by negative 2, you divide by negative 2. You get x is equal to positive 3 all over 2. So you can see that the same x that we got here to be 3 over 2, still we're getting the value to be 3 all over 2. So you can see it is common. That means you can write one vector. The vectors are multiples of each other. So we can come back to this and replace, so that you will say 3 all over 2ab is equal to bc. And having done that, then we can say that vector AB is parallel to vector BC. Vector AB is parallel to vector BC, because we can write AB in terms of BC. We can say that BC is equal to 3 all over 2 AB, or this is the same as AB is equal to 2 over 3 of BC. So this is how we test whether the vectors are parallel or not. Then having satisfied one condition, so we can come back here and say that the vectors are parallel. And now we need to see whether there is a common point. So you can see that there is a common point. B is common. B is common. Therefore, A, B, and C are collinear. Having satisfied those two conditions, then we can conclude that indeed point A, B, and C are collinear. So that is how we test the collinearity of vectors. You first of all check whether the vectors are parallel, or you are given the points, 3 points like that, you form two vectors, that is AB is to BC, AB and BC, and then now you find their vectors, you find whether there are multiples of each other. Then having satisfied that, then you can see whether there is a common point. And if that is done as well, then you can conclude that the points are collinear. So I believe you have understood how to do that. Let's consider our second question, or our third question. In vectors, you're told, given that OA is equal to 3i plus 4j plus 7k, OB is equal to 4i plus 3j plus 9k, and OC is equal to I plus 6j plus 3k, show that points A, B, and C are collinear. So you can see that you have been given these vectors in terms of unit vectors. So, and I believe you understand that unit vector is a vector with magnitude of 1. So what we can do here is that we can change these unit vectors to be column vectors. So we know that OA now will be equal to, if you write this as column vector, you know that unit vector along the x-axis, which is normally denoted by I, is 1 0 0, like that, if it is a 3-dimension, like that. And this is unit vector along what? Along the x-axis. Along the y-axis, which is normally denoted with J, is 0 1. Sorry. So this is 0 1 0. And along the z-axis, which is normally denoted by K, is 0 0 1, 0 0 1, like that. So this just to remind you about the unit vectors. So you can see that is how we write the unit vectors along that. So if you want to write now OA vector OA in terms of as column vector, then we can say that OA will be equal to 3 multiplied by unit vector along the x-axis, which is 1 0 0 1 0 0, plus 4 multiplied by unit vector along the j-axis, I mean along the y-axis, which is denoted by j, that is 0 1 0, plus 7 multiplied by unit vector along the z-axis, which is 0 0 1. So this will give us 3 0 0 plus 0 4 0 plus 0 0 7, which will give us 3 plus 0 will get 3, then 0 plus 4 plus 0 will give us 4, and 0 plus 0 plus 7 will give us 7. So this is vector OA in column form. It is 3 4 7. Then we can also consider our vector OB, which is given as in unit vector as 4i plus 3j plus 3j plus 9k. So that is how it is in unit vector. So just like the way we have done the first one, it will be 4 into bracket 1 0 0 plus 3 into bracket 0 1 0 plus 9 into bracket 0 0 1. So this will give us 4 0 0 plus 0 3 0 plus 9 0 0 0 0 9. And if you add the corresponding elements, you will find that this is 4, this is 3, and this is 9. So that is the unit, that is the column vector of OB. OC as unit vector is given as I plus 6j plus 3k. So if you are keen enough, you will find that it is just the short way of writing this is that you just write this as the first row, that is you write the coefficient 4, second row is 3, third row is 9, like that. So you can omit these steps if you are able to. If you can write, you can follow a shortcut so that you get quickly OB. Like now in this case, now the coefficient of I is 1, so you just say 1. The second row will be the coefficient of j, which is 6, and then the third row will be the coefficient of k, which is 3. So in short form, you can just write, you can easily write the unit vector in as column vector, like that, instead of following all these steps. Okay, so we say that if you are given a position vector, because you can see all these are position vectors, you can draw something like a triangle. You can draw something like a triangle, just the way we did in our first case. So this is O. You can put another point here. So this can be our A, this is B, and this is C. So this is OA, vector OA, vector OB, vector OC. So we know that vector OA is 3 4 7. Vector OB is 4 3 9, and vector OC is 1 6 3. So the question was that you check whether these points are collinear. So what do? Our first step was to form vectors from these points. We form vectors from these points A, B, and C. So we can look for vector AB and vector BC. So we form two vectors, vector AB and vector BC. You can see that there is a common point which is B. So now let us find vector AB. So vector AB will be AO, which is negative of OA, so it is negative of 3, 4, 7 like that, plus OB, which is 4, 3, 9. So negative 3 plus 4 you get 1, negative 4 plus 3 you get negative 1, and negative 7 plus 9 you get 2. So that is vector AB. You simplify this, negative 3 plus, and then you add, you get 1, and then negative 4 plus 3 you get negative 1, then negative 7 plus 9 you get 2. Then we need to look for vector BC. So vector BC is the same as BO. So this is the same as BO, which is negative of OB. So it is negative of OB, which is 439, plus OC, which is 163. So this is negative 4, negative 3, negative 9, plus 163. So this will give us negative 3. Negative 3 plus 6 you get 3. Negative 9 plus 3 you get negative 6. So we can see that our vector AB is equal to 1, negative 1, 2, and our vector BC is equal to negative 3, 3, negative 6. Yeah. Okay, now we want to see whether these vectors are parallel. So just as we did before, we will say XAB is equal to BC. So we will form equations. 1, negative 1, 2 is equal to negative 3, 3, negative 6. So you can see that this is x is equal to negative 3. That's our first equation. The second equation will be negative x, because this time this you get negative x is equal to 3. You make x the subject, you divide by x by negative 1, you divide by negative 1. So still you get x is equal to s is equal to negative 3. And if you want to test your answer with the third equation, it will be 2x is equal to negative 6. You divide by 2, you divide by 2. So still you get x is negative 3. So all of them will give you the value of x, which is negative 3. So we can say that our x is negative 3. So we will say negative 3ab is equal to negative 3ab is equal to BC. This means that these two vectors are parallel. So that means that vector AB is parallel to vector BC. So we have met one condition, that is whether the vectors are parallel. And also we can see that and B is common. B is common, which is the second condition. Then we can say that vector points A, B, and C are collinear. So that is how we test the collinearity of points. You check whether the vectors are, you form two vectors, you check whether they are parallel, that is if they are multiples of another one, then you see whether there is a common point, then now we can conclude that they are collinear. Thank you so much. Remember to subscribe so that you are updated with the subsequent postings. Thank you.